Calculus Explained, and today we are going to be covering basic derivative rules. So last video, we used the definition of the derivative. It worked, but it was really slow. Imagine doing that for every single function. Calculus would be unbearable. So the derivative rules are the results of the definition, which are shortcuts to computing the derivative. So today we'll learn about those rules that lets us take derivatives in seconds without losing the intuition behind it. So first, let's start off with a constant rule. If f of x equals c, then f prime of c, which is another way of saying the derivative, equals 0. So a constant doesn't change, so its rate of change is just going to be 0. If you think of it graphically, you'll have a horizontal line, so the slope everywhere is going to be 0. An example of this is f of x equals 5. So then f prime of x is going to be 0. Now let's look at the power rule. If we have f of x equals x to the n, then f prime of x equals nx to the n minus 1. This is a crucial formula in calculus. We will be using this formula very often through our calculus journey. You will get very comfortable using it over time, so it's important that you pay attention to it now. Let's say we have f of x equals x cubed. Then f prime of x equals 3x squared. If f of x equals x to the 5th, then f prime of x equals 5x to the 4th. Now in another case, let's say that the exponent is negative. We'll say negative 2. Then f prime of x is just going to be the same thing. Negative 2x to the negative 3rd. Let's say that it's a fraction. How about 1/2? Then f prime of x is going to be 1/2 x to the negative 1/2, which is just 1 over 2 root x. If we have f of x equals x to the pi power, then f prime of x is just going to be pi x to the pi minus 1. So the point I'm trying to make here is that the derivative power rule works for any and all powers that are real, whether it be positive, negative, fractional, irrational, whatever it may be, the power rule works. Now let's look at another rule, the constant multiple rule. This is very useful for simpler computations. So let's say we have c times f of x. Now the derivative is just going to be c times f prime of x. Really, you can just pull out the constant, and then you can compute the derivative from there. If you think about this, multiplying a function by a constant really just scales the slope. So it makes sense that you can just pull out the constant when you're computing the derivative. If we look at some examples, let's say f of x equals 7x cubed. Then f prime of x equals 21x squared by using the power rule as well. Now let's look at the sum and difference rules. So if we have d dx of f of x plus g of x, this is going to be equal to f prime of x plus g prime of x. So really, you can see that the that the derivative rules are distributive. You can distribute them across addition and subtraction. So let's look at an example of a polynomial. Say we have f of x equals x cubed plus 5x squared minus 7. If we compute the derivative, we get 3x squared plus 10x minus 7. This is because this just becomes 3x squared, this becomes 10x, and this just becomes 0. So you can see that we can differentiate term by term to get the final derivative. This is why polynomials are the easiest functions in calculus. It's super easy to compute them because you can just use the power rule for everything. Now remember the definition of the derivative. If we have f prime of a point, let's say c, then that is the slope of f of x at x equals c. So remember that when we're computing the derivative, it's not just a formula, it tells us how steep the graph is at each point. So we see that, for example, if in a real world situation, f of t is position, then f prime of t is your velocity. This is because velocity is just the rate of change of position. So now let's look at some practice problems. We'll say f of x equals 4x to the 5th minus 3x squared plus 1/2 x to the negative 2/3 plus x plus 9. Then we'll do another f of x equals 2 over x to the pi. And lastly, f of x equals 10x squared plus 3x minus 2 over x. So go through these on your own, pause the video, and when you're ready, we'll go through them together. Welcome back. Let's start off with this first problem. We differentiate term by term. This becomes 20x to the 4th minus 6x plus negative 1/3 x to the negative 5/3 plus 1. And then this cancels. So then that is f prime. Next, we see an x to the pi on the denominator. We can simplify this to get 2x to the negative pi. This means f prime of x equals negative 2 pi x to the negative pi minus 1, which is negative 2 pi over x to the pi plus 1. Lastly, we see f of x equals 10x squared plus 3x minus 2 over x. We rewrite this as 10x squared plus 3x minus 2x to the negative 1. Differentiate term by term. Get 20x plus 3 plus 2x to the negative 2. That is f prime of x. And we can simplify this to get 20x plus 3 plus 2 over x squared. And those are our answers. So we've built the foundation of differentiation. Next, we'll look at functions made from products and quotients where these simple rules aren't going to be enough to solve the derivative. I hope you enjoyed this video, and I will see you next time.